Hello and welcome to the video on topic 2B. 2B, where we are talking about measures of center and variability. Now, in the previous video, 2A, we acquired the knowledge for how to measure or how to calculate a measure, a number, that represents the two key properties of my distribution coming from a set of scores. The position, if you will, center, and the spread around that center. How quickly does it drop off, or does it extend very far in either direction? The variability. So all we're doing right now is we're going to look at an example, and I'm going to do number 13, which comes from the Statistics for Psychology book that we mentioned in the introduction video. I get different examples from different books. I want to do number 13, and all it is a set of scores, 1, 2, 3, 4, 5, 6 of them, and we want to calculate all the things we talked about last time. The mean, the median, the mode doesn't make much sense here because none of them repeat. Like we said, mode is more important for categorical variables. Then we'll move on to the variability calculations, sum of the square deviations, variance, standard deviation. All right, so let me just open it on my other screen here so I back and forth. You can pause, write these 6 numbers down, and we don't have to look at this all the time. But we are doing number. So our scores, let's write them down here. Scores are 3.0, 3.4, 6, 5, 3.2. So that means our n is equal to 6. There are 6 of them. Now in these calculations, you're welcome to reference the formula sheet. So when it comes to the mean, we are using formula 2.1, which adds up all the scores, divides them by the number. That, because that is the first thing we want to do. But I want to write down here, I'm calculating the mean. So we're calling it M for mean. Sum of all the x values over n. Now the sum of all of these, I will have to do in my calculator. I'm using my Discord channel MathBot to do that. Let me just warm up MathBot and see if it's awake. Check if it's awake. Seems to be awake. Good job, MathBot. So now I want to add them all up. So let's do it. 3 plus 3.4 plus 2.6 plus 3.3 plus 3.5 plus 3.2, and we get, I want to show some work here, right? Some steps to just verify that I am in fact doing what I claim I do. And then we want to calculate, we get a sum of 19. We want to calculate 19 divided by 6. And we'll just round to, I don't know, 2 decimals should be fine. 3.1. That is the mean, 3.17. Let's reference the question again. Mean. Median is next. So, going to calculate the median. How do I do that? Well, I have to arrange the scores. Luckily, I only have 6. I can do it by hand, right? Smallest one, so let's say here. use words. Say what you're doing. Arrange the scores. 2.6 is first. Check. Then 3.0. That one's done. Then 3.2. That one's done. Then and you can see that this will not be the easiest thing to do if I have a lot more scores to work with. But luckily, we're doing it by hand, so the question understands that number of scores can't be that big. So I have 6, so halfway in, these two, average them out, 3.2 plus 3.3, leave no stone unturned, show all of it. I can even do it in MathBot if you're not sure what that is. I'll need a bracket. 3.2 plus 3.3, close my bracket, divided by 2, and I get a random line, as well as the answer 3.25. So there is my median. Put a box around it. Median. They're pretty close, as expected. So, next up, we want to calculate the variance, and to do that, we have to get the deviations and square them and all kinds of stuff. Good times. So, let's say it in a table first. Well, I'm going to calculate the variance next, but to do that, I need some work first. I have my scores. Mean I have here is 3.17. So then I'll calculate the deviations. And then I will square the deviations. And that should be sufficient. Now we don't have a lot. We only have 6. But still, I'll leave them in the original order. Really doesn't matter, right? As long as I do them all. 5, squeeze in 3.2. Now the deviations here, I will just clarify one of them, the score minus the mean. I'm not going to write all of them out. We just need to calculate them. 3 minus 3.17. I'll always get a random line when I switch back into this window. Negative 0.17. Next one is the score 0.4 minus 3.17. If you think this is tedious, it's supposed to be when it's done by hand. To give me an appreciation when I can automate some of these things. Next score, 2.6 minus 3.17, the mean. Get a negative 0.57. And you'll see everything below the mean is going to get a negative deviation. Of course, everything above will be a positive deviation. Halfway there, 3 minus 3.17. So easy to do something wrong. Let your finger slip on the calculator. So easy to do. Even when it's the same thing over and over and over. Out. Where was I now? I did not put two equal signs in. Go. Oh, seriously. I pressed my undo button too fast to get rid of this line. It is not happy with that. This way. Can I still draw? Okay, it's not completely unhappy. There we go. Stop using my shortcut button. Anyway, I get a 0.33 deviation. One more. That column. 2 is the score, minus 3.17. I just need to slow down with this drawing. 0.03. Now I have to square them. Now make sure, just in case it happens here or in other situations, don't round these temporary answers. I need to be as precise as possible. I can only round a final answer. Don't round things on the way if I need to use them in a future calculation. Now, the whole point of squaring is to get rid of the negative. So when I square them, I don't have to type the negative. Make my life a little bit easier, right? Because the whole point is going to be a positive. I have to write down all the decimals here. If I round here, then when I add them, that answer won't be perfectly accurate, which means my variance and standard deviation won't be either. Just be aware of that. Next one is 0.23 squared. It has value to do this by hand. Not the hardest thing to do once you get used to it. Definitely do at least one by hand. Solidify that understanding. See people rush to asking, which is a risky game for me. Speaking and doing something else, I have to be careful. I see people rush to the statistics software and things like that too fast. Don't really understand what they're doing. MathBot is slowing down too. Come on, MathBot. 6, 9. Two more. It's very important to suffer through a couple, however many you need, by hand. Gives you time, slower paced, and sure you know how these things are done. Yes, in some cases, some calculations are a little bit fancy for us. We're not necessarily like the skewness index, things like that. Those that at this stage anyone wants to do by hand. But these fundamental calculations we definitely need to understand completely. Okay, I made it to the end. Now I have to add those up. Add these up. Only the square deviations, right? And this is going to be the sum of the squares. Make sure I type correctly here. Very important. 0.0289 plus 0.0249 plus 169 plus 1089 plus 0.0009. Sum of the squares is 0.5334. Now this is one of the things that they are actually asking for. So I guess I'll put a box around it. Then the variance, which we will name, represent as d squared, is going to be, well, we're learning, right? Let's consult our formulas. You always have access to this. Formula 2.2, we've done the sum of the squares at the top there. So it's the sum of the squares divided by the versions here. I've done this. X minus mean squared and then adding them up. That square sits a little bit. So it's the sum of the squares divided by how many there are. That means it's 0.5334 divided by 6. Let's see what we get. Are we still on the screen? Yes. Calculator time again. 0.5334 334 divided by 6. Now, be careful here as well. People often make rounding mistakes and they don't realize that if I round something and use it in the future, then my answer won't be correct. This is what I get. If I had to round this, I could say here it's approximately 0.089 if I want to round to two significant decimals, but let's not even bother. If it's a repeating decimal, it goes on forever, I definitely want to round that. But when I use it in the next part with the standard deviation, the rounded number, that's simply going to be the square root of this, but in this case, luckily, I have a terminating decimal. Just be aware of rounding. Square root has this function in MathBot, 0.0889. That is going to be a longer one for sure. 0.0 if I round it. I'm going to write down the whole thing just because this is our first example, just to illustrate here. But because this is a final answer, I can round to two decimal places and say 0.30. But be aware when I can round. And even if I present this, let's suppose later on there's a future calculation using the standard deviation. I present my answer as 0.30, but if I were to use the standard deviation, for example, in a further calculation, don't use this, use the precise value. Okay. Be aware of that. And there we go. Those were all the things that we covered in topic 2a. And we have now done number by hand. Next up, I want to do one by hand again, but using a spreadsheet to just make my life a little bit better. I still have to do a lot of it manually. It's not done for me and just popping out these key numbers. I'm still formula doing something that requires understanding, but the spreadsheet can make my life much, much nicer. Till next time.